This is a mini lecture on an overview summary of complex fraction. This is the last part of Module 2. Now, a complex fraction is just a fraction with whose numerator and denominator contain fractions in them. It needs to be simplified. And I'm going to show you that the simplification process, a complex fraction with rational expressions such as this one, is going to be similar to a complex fraction that has only numbers. First step is to rewrite it as division. Flip the divisor and multiply instead. So here we rewrite this complex fraction as division. So flip the divisor and multiply instead. Factor what can be factored. So this last denominator will be factorable into 3x minus 4. So note now that you can cancel out the common factors. So it gets simplified to just 2x to the 4 over x minus 2. First, rewrite the complex fraction as division. You flip the divisor and then multiply. You factor what you can factor and cancel common factors. Now go to the second page. We have a complex fraction that looks a bit more complicated, but we just apply the same process. Write it as division. Flip the divisor. Okay. Cancel common factors. You can do it earlier, not necessarily the last step, because as you can see, we can already cancel 3 and 6 here. W cubed, w to the 4, that gives us just w. So this becomes w minus 5, 2w, and w squared minus 10w plus 25. The bottom is factorable. So let's factor it on the side here. This is going to be ww. This is a plus, but the middle is minus, so our only choice will have to be minus minus here. 25 is factorable as 25 times 1 and 5 times 5. 5 and 5 will work. So if you FOIL, you will get it back. You could also have noticed that this is just the square of a binomial. So you can right away say that w squared minus 10w plus 5 squared is w minus 5 squared, coming from the formula a minus b squared is a squared minus 2ab plus b squared. So in this case, the a was 1 and the b was 5. So now, writing out in factored form, we will be able to cancel common factors. So the reduced form is 2w over w minus 5. Sometimes, when there are many fractions in the complex fraction, it is better to use the LCD technique. You get the LCD of all the fractions that appear in the complex fraction. In this numerical fraction, that will be 2 times 5 times 7 because they are all prime numbers. So this becomes 70. So what we do is we multiply top and bottom by 70 and distribute it to the fractions. And then we cancel common factors. So 5 into 70 is 14. 7 into 70 is 10. 2 into 70 is 35. 5 into 70 is 14. So we're left with 4 times 14 plus 6 times 10. 35 plus 14. The fractions are all gone now. So this reduces to 114 over 49. So here we have fractions 2 over 6x and 1 over 12x. The LCD is the LCD of the 6 and the 12, which is 12, and the x and the x, which is x. So we multiply top and bottom by this LCD and distribute it. And this will give us 3 times 12x plus 2 over 6x times 12x all over 12x minus 12x over 12x. Now cancel common factors. 6 goes into 12 twice, and x cancel. These guys just both cancel. So now we're left with 36x plus 4 all over 12x minus 1. And we factor what we can factor. So we have to take out 4 at the top, and this leaves us 9x plus 1, 12x minus 1. That's it. So the procedure is to get the LCD of all fractions. You multiply numerator and denominator by the LCD. You distribute the LCD. You simplify and cancel common factors if there are any. Okay, the last topic in Module 2 is rationalizing the denominator. That means we don't want to see square roots in the denominator of any fraction. So for 4 over square root of 7, it's simple what to do. You just multiply both top and bottom by square root of 7. Square root of 7 times square root of 7 is 7. So no more square roots below. The principle that we used here by just multiplying numerator and denominator by the radical itself is that the square root of any number times itself is just going to be the original number. Now, if you don't have a single square root appearing at the bottom, but you have these companions, you do what we call conjugation. The conjugate means you will turned that into a plus. Okay, so we multiply by 7 plus 3 square root of 2, 7 plus 3 square root of 2. Now, let me write that here so that you can see that this is really a difference of 2 squares. So, this becomes 7 squared minus 3 square root of 2 squared, which is 49 minus 9 times 2. 49 minus 18, which is 31. So the bottom is 31, and the top is minus 3 plus 7 times 3 square root of 2, which is minus 21 minus 9 square root of 2 over 31. So we got rid of that square root of 2 below by using this process, which is, by the way, called conjugation. The principle behind conjugation